I am a researcher here at my favorite museum, the Arizona Museum of Natural History. Thank you all for coming out tonight. This may be a few minutes longer than the hour they allotted because, as Bob not so alluded to, I made a judgment call. And so I shifted to Holotypes of Arizona because I was curious. As I started doing my original talk, I realized I didn't realize how diverse the animals of Arizona are from a fossil standpoint. I figured, well, if I don't know, most people won't know. And that's kind of arrogant, but it's also true in this case. So we'll start off with what's a holotype, because the holotypes are all I'm going to be talking about. And the holotype is what we call, when you name something, like when Linnaeus gave Homo sapiens a binomial, he had to choose a bone to represent something that we can all go and compare to. Did I find a Homo sapiens? Now, he used himself, so that's arrogance. Thank you, Linnaeus. But the holotype is what we call the name-bearing bone. And that's the bone that if we find a fossil in the field and we want to know what we found and we think we might have an Arizonosaurus, we come and find Arizonosaurus and set our bone next to it. It's the same or it's not. So most states have 5, 10, 15 taxa from them. But Arizona has an incredible amount. So why? We talked about it. There are 59 plus or minus unique vertebrates. And by unique, they were named in Arizona first. Now, some have been found in Texas, New Mexico, Utah, South Africa, other places. But for the most part, these are found only in Arizona. And you have to make a decision, just like a museum. Do you want to walk people through time, start at the beginning and move linearly forward, which is what I chose tonight, or do you group the animals? And I vacillated, and well, you all tell me when we're done if I should have just put all the amphibians together. But I like going through time because it tells a story of evolution. And when we're within a time period, we're going to talk about a formation, so a kind of rocks that where fossils are cut and they have a date to them. And then we'll talk about from the most primitive to complex. So we'll start with fish, sorry Ben, and we'll work our way to mammals, but dinosaurs are my favorite. So I hope you leave with a tremendous appreciation of diversity of fossils in Arizona. We have what turns out to be an extraordinarily rich amount of animals. I also want you to realize how important a fragment is, because what I am showing you are the holotype papers. So these are the first papers written. So if you're a researcher who lives on the other side of the world or California and you are trying to figure out if you found the animal, short of visiting it, all you have are these pictures I'm showing you. So you'll get an appreciation for how tough paleontology can be and how important fragments are. So please be aware of I apologize profusely for using AI artwork. Fossil Crates is a massive supporter of actual artists. However, for all but 12 of these taxa, there was no art. And it'll make sense when you see why there was no art. It'll like, oh yeah, I get it, why no one drew this animal. So I had to show something, otherwise you'll see a chunk of bone and kind of blurry pixels, and that's not ideal. And I'm a completist, which is why I might run a few minutes over. I figured once I got my claws in, I could not stop until I touched every single holotype in the Mesozoic in Arizona. So, super excited. Lastly, this is going to go pretty quick. I don't expect you to have heard of all but maybe 2 of these animals. So it's a speed bag of just take in the awesomeness and the diversity of Arizona. So we'll jump right in. Just for the geologists out there, these are the formations we're going to cover. Moenkopi, Chinle, Kayenta, Navajo, Turney Ranch. 5 fossiliferous zones in the Mesozoic of Arizona. Each of them tell a different story about the environments. And we're going to start off at 245 million years ago from today. We're going into the Moenkopi. So at the middle of the Triassic, and what we had is a coastal floodplain. We have slow-moving rivers, they're meandering around, lots of mud flats, and it's humid. It's very warm. The best part about it, though, is it's kind of like today because it's humid and muggy with monsoons, and then it's really dry like now. And we'll start off with, this is kind of what the environment looked like, just a wide-open, flat, muddy environment. The part of the world we're talking about is up in the northeast corner of Arizona, right here, the Moenkopi Formation. And we put some locations, some GPS coordinates, but you probably shouldn't see some of those, I'm sure, but old papers shared things modern papers don't. So we'll move past that, actually. And we'll start off with something that first animal out of the gate surprised me. This is something called Moencopia. I'm like, well, okay, it's named after the formation, but what is it? That's what we found. we found a neck bone and a part of skull. Believe it or not, fish are weird and have bizarre skulls. So what is it? Well, it looks something like this. It's a kind of coelacanth. So you may have known coelacanths from the living fossils that were found 1914-ish, that had been extinct for 70 million years. Well, we had one living in Arizona 245 million years ago, swimming in those rivers. So I thought that was kind of cool. I had no idea. I'm born and raised here, and I never knew that we had a coelacanth in our state. I said, well, that's kind of cool. But that's the only fish we had 245 million years ago that's new, and it was found uniquely in Arizona. Now, amphibians today, you know them as the beloved frogs, newts, salamanders. Our good friends, we traveled all over Japan to look at these, and Ohio. But this is a Sicilian. No, that's not an Italian. It's a legless amphibian. I won't move on from that quickly. It'll come up though. So the first one is I'd never heard of, Cos griffius. You're like, well, what is Cos griffius? Well, this is all they found of it. That is a very long snout. We have this cast on display in the museum. So after the talk, if you want to go over and look at a few of these, this is on display. There's its eyes, really long nose. So imagine like a newt or a salamander with an extremely long snout. Now these are about 4 or 5 feet long. There's that long snout, and it's an amphibian. So you have an amphibian that is larger than any living amphibian today, hanging out 245 million years ago, which tells you it was warm, moist, miserable environments that we wouldn't want to live in. Now, another amphibian is called Cyclotosaurus. Well, the word Eo means dawn, so Cyclotosaurus is a common amphibian found throughout the world. Well, this is a very early version of that amphibian. Now, we found the skull. This is the holotype. So this is all researchers had to work off of, was this. I love how they drew the real side and then they labeled all the bones. So for a guy like me who can't figure out, well, what bone is that? Well, they've got the labels. Oh, look, that's the frontal, that's the nasal, that's the lacrimal. Cool. One other thing else to note, look how narrow. It looks like a Star Destroyer. If you like Star Wars, there's the Empire. That's where they took inspiration from it. This is a cast. I believe we have a cast of this on display as well. And this is kind of what it looked like. It's just this big, blobby, 3-4 foot long amphibian. And these all were ambush predators. With that wide mouth, they pop their mouth open and spring out and get a fish or something living on land. Paleontologists are not creative. We have Cyclotosaurus, we have Eocyclotosaurus, now we have Quasi-Cyclotosaurus. It's almost Cyclotosaurus. Why not name it something new? I don't get it, but all right, that's okay. This was in 2000, so there was some incentive to name things at this point. Here's what they found, a skull. Again, the same classic drawing on the right, labeled it on the left. This is the ventral side. Notice it has teeth in the roof of its mouth. So these are amphibians that you did not want to get bit by, because not only would you get one row of teeth, but if you got your finger in far enough, the second one's going to get stabbed. That's no bueno. And this is what the original skull looks like. I went and found a 2016 paper to show you. These are these flat. See how thin it is? That's on its side. These are very strange creatures. We don't have much like them alive today except the giant salamander in Japan and Ohio. So again, no one's drawn these animals, so here it is, that big wide head. They all look the same. Notice, there's no postcranial elements. In many cases, we didn't find them, but in other cases, they chose not to describe them because they said, they all look the same anyway. Everyone loves skulls. Paleontologists are a bunch of headhunters. So, Hadrochosaurus is the stout-toothed lizard. So you're thinking, well, that's going to be pretty cool. And this is what we found. You found a jaw. Yay, I got a lower jaw, and that's all we have of it. But from this lower jaw, look how weird the tooth is. It's leaning in. Very different. So this kind of animal, every one of these bones, if you really took the time to look, they're different from one image to the other. You can tell they're not the same animal. And here's the other picture of it, because again, if you're working from somewhere and you can't go touch the bones, this is all we have to work from. Even today, one of the great limitations of paleontology is images. If they only give us this is all I can use. It's frustrating. Now, modern technology comes in, and that was 1947. We get a photograph, and you can see how weird this bend is. Very different. And so, no surprise, it looks very similar to the other critters. But the funny part about this was this thing had a top that had always been associated with it. This skull here, again, the low flatness, had been called Hadrochosaurus, But some intrepid paleontologists realized, hey, there's some differences. Even though we have a lower jaw versus an upper jaw, how would you know? We'll show you in a second. And so this cast is on display. These amphibians have pineal eyes. So that third eye sitting on the top of the head, it's kind of creepy when you look at them. And these are giant. I mean, the skull itself is on display is about yay wide. So this is a good thumbprint wide. So they were doing something. There weren't really any flying predators because that's what they're useful to detect shadows. So if something's coming at you. But if you swim in the water and you want to know if a predator is coming at you from above, it still has value. This is what it looks like. I added the third eye. I thought that was pretty cool. But here's where paleontologists get funny. This was the lower jaw and upper jaw were said to be the same thing. But someone noticed that this angle and this angle do not correspond. And therefore, they cannot occlude, so they can't be the same taxon. So they have to be two different animals. So they named it Vigilius. And it was named Vigilius in part because it was found over above the Grand Canyon, looking, when they excavated, they could see the Grand Canyon. So these individuals had a sense of humor instead of quasi or neo Cyclodosaurus and chose to call this Vigilius, where it's looking out over the canyon. That's a lot of amphibians, and these are big amphibians. There are a lot of amphibians that I did not talk about because they're known from other places first, and then we found them here. Now, reptiles, as you know today, are quite diverse. Tortoises, turtles. We have, by the way, the best turtle tortoise team in the world is sitting in Arizona. Between Bob McCord and Heather Smith and her crew, there's no finer turtle researchers. So if you like turtle paleontology, this is the mecca of it all. Which makes me giggle because I like horned toads. They're cool. And lizards. I got my bucket list fulfilled last year. I got to hold a tuatara. That was neat. I'd always wanted to do that. It's not a lizard, though it kind of looks like one. It's technically a rhynchocephalian sphenodontian. Big words we like. Crocs, alligators, snakes. So let's see what the reptiles looked like in Arizona 245 million years ago in this wet environment. The first one up is a Nisodontosaurus. Now, usually back in the day, this is 1947, the old timers, they didn't go for things like today. There's a dinosaur called Thanos and Gremlin and Zool. These are real names. Moros. These kill me. It doesn't tell me anything. A Nisodontosaurus tells me that it's an unequal toothed lizard if you know your Latin or your Greek. And sure enough, they've got wonky teeth, unequal. You've got little thin ones down here and big ones up front or in the back. The funny thing is, that's the only bone we have of a Nisodontosaurus. We know it doesn't look like any other animal that's ever been found. That's why we got to name it new, but we also don't know what it looks like. We're just wildly guessing. So this is wild speculation. Thus why there's no art made for it, because who's going to draw that little jaw when we have no clue what it is? But happily, AI did it. So it does have a purpose of making stuff up. It hallucinates. Now, Rhabdalognathus. There's a mouthful, but they get better, I promise you, name-wise. This is named easily broken jaw. Again, 1947. And you're thinking to yourself, well, what do they mean by an easily broken jaw? Well, this is it. It was easily broken. So they lost the center, so you got the back and the front, and that's it. That's the only bone we have of this animal is a lower jaw that was easily broken. And we also have a couple bits later on from skull on the top of the skull. But there's that long jaw. Doesn't look like any other jaw that's ever been found, so we name it something new and exciting. And we know it's a reptile because of the teeth, so perhaps it looked like this? We don't know. All we know is a lower jaw. And this is a problem because if I go to this place and I find a humerus or a tailbone, how do I compare that to the named bone, which is a jaw? It causes all kinds of problems. Paleontology may look great at Jurassic Park level, but when you get into the weeds, it's all gray and makes you pull your hair out. So Amorhynchus, this one's called sand snout. And you're thinking to yourself, all right, that's kind of cool. Our prodigy here, Sterling Nesbitt, named this in 2004. Sterling Nesbitt is one of the best paleontologists around, and he started here as a middle schooler, working in the prep lab as a volunteer. And he worked his way through working to where he got to go in the field. So if you have little ones that love paleontology, we have proof positive with Sterling and others, but Sterling is the most, I guess you could say, famous in the paleo world. Sterling's amazing. So I'm going to ask Sterling about this, though, because these are the only pictures he gave us. He found this. I'm like, what even am I looking at here? And I'm a professional. So I stared at this for quite a while, and then I cheated and looked at his drawings. I go, okay, there's lingual teeth. So there's teeth, this must be a jaw, and lingual means tongue side. So this is a piece of lower jaw. There's some pictures of it. This is all we have of this animal. But we have no animals that have these teeth popping out the side of the jaw. So we play with these mysteries. It's super tantalizing. The Arizona has so many specimens that we just need to find a little bit more, and we'll know a lot more about the animals. Discovery is ripe up in northeastern Arizona. Based on some of the teeth, it's thought to be a trilophosaur, and they have beaks, so that's why we put a beak on it. Paleontologists are dependent upon comparative anatomy. If you find this bone here, you need to be able to know what bone it is, humerus, radius, ulna, and then you go and you compare it to all of the other bones of that same type, and you start putting together a story as to what you have. Arizonosaurus, believe it or not, it was a real dinosaur, but it's not a dinosaur. Saurus just means lizard, not dinosaur. I wish we could have monopolized it. So the Arizona lizard, named in 1947. Now here's the frustrating thing. That's all we had of it. They found a chunk of jaw, and they found a tooth, and they knew this tooth and jaw shape looked like nothing that had ever been found. So we got to call it Arizonosaurus. That's what Sam Wells named it. However, aforementioned Sterling Nesbitt comes along and finds a whole bunch of the skeleton, all the bones in white. That was super cool. So he was able to take what was a marginal animal sitting on a shelf somewhere and turn it into a tour de force in paleontology of the Moenkopi 245 million year group in the Triassic. He's got all these different elements, and I commissioned artwork to show it. Being Arizona, you gotta put the money out for my home state. However, notice I don't have any spines on it. I made it like a camel hump. The other interpretation is that you could see the spines. So even there, we don't know. There's so much mystery. And one of the great things about paleontology that keeps me interested, and children of all ages, is that, is it a hump or is it visible? How can you tell? So you start looking at other animals that have humps and other animals that have, like a chameleon where you can see them on the back, and then you look for characters in the bone. So again, comparative anatomy. It's always a treasure hunt in paleontology. We're done with 245 million years ago. We're going to leave the swamp, and we're going to move into 10 million years forward. We're leaving the middle Triassic and coming into the late Triassic. And the world has changed because now we have these huge, giant river systems with huge conifers, giant trees that are hundreds of feet tall. The petrified forest is made up during this time, all the trees. So it would get dry, but for the most part it was quite wet. So let's see what that does to the animals that we're looking at here. Here's an overall picture of what it might have looked like with meandering streams, oxbow lakes, or oxbow cutoffs. Really cool stuff. So we're, again, in the northeastern Arizona. All of the land that we're looking at, petrified forest is the greatest place to go because you can see all of it at once. But we're going to start with a shark called Reticulotus. So Arizona had not only a coelacanth, but we have a shark. And this is the shark's teeth. They look like little buttons. That's a millimeter for scale, so that's very tiny. And when you zoom in, you can see lots of flat plates. So we know that sharks that have flat plates today often eat things from the bottom and crack open shells. So they're not eating fish. I mean, they can, but they're really not targeting them. These diagrams are absolute gold for paleontologists like me because I don't know what shark teeth, how do I know which way is up? So thankfully, they were very kind and they drew me this schematic. They drew it just for me. I mean, it's for all of you, but I really enjoyed it. So thank you, authors. This is a Port Jackson shark modified to be 235 million years. When they say sharks are living fossils of a sort, they are. We also have amphibians again, so we're back to our friendlies. And we have Fungus vermis, the funky worm. Some of you may have heard about funky worm because he was named in 2023 from the crew at Petrified Forest. And he is a caecilian, and that's those legless amphibians. And we have all these beautiful jaws. Now let me put you to the scale, 1 millimeter. So these are less than a centimeter long, all in. And the way they find these is, to me, I study sauropods. My animals are 100 feet long. I break off more chunks of bone inadvertently than this entire animal would have in it. And they use fine micro tools. They work under microscopes. They use needles to put these together. The work they do up there is extraordinary. And I'm just showing you the pictures, all of these jaws they have, and caecilians have very distinct teeth. So it's nice when you find a jaw with teeth in it, you know you found one. That's cool. So this is the oldest one of these, as far as I'm aware, Funcus vermis. And this was done by a professional paleo artist named Andrea Tuchin. So really great artist, wonderful discovery. It pushed back these legless amphibians a solid 10, 20 million years, which is cool. Notice I said 10 to 20. One of the things that I loved about paleontology is I can say 10 million years plus or minus 5 million years and no one blinks an eye. Try telling that to an accountant. That's not going to fly. So paleontology lets me be lax on math, close counts. But that's it. That's the only amphibian. We had one. Remember before we had half a dozen amphibians. So the environment is shifting. The novelty is changing. And now reptiles begin to take over in the late Triassic. So we have some of my favorites, Microzymiotes, which is the small punisher or avenger, depending on how you want to translate it. That's the only bone of it that's known, which you're thinking, well, that doesn't do much. However, when you see this groove here as a paleontologist, your heart gets 3 sizes too large because that is a venom groove. This is proof positive that we had venom in a lizard-like animal 235 million years ago. Animals were using venom to subdue prey. And without this, we wouldn't have known. And you can see here this beautiful groove. And because we have the jaw, we could see the delivery system. It was amazing. So these get special CT scans and scanning electron microscopy. They pull out all the big guns for these types of specimens. So it's a chunk of jaw about, I don't know, between my fingers long, very tiny, and extraordinarily important for telling a story. And here's, who knows, all I have is this part right here. But I made it look like a lizard. I thought that'd be fun. But I don't know how to say this. Uachitodon, I'm going to go with it. And what we have here is this single tooth. So we thought 3 teeth in a jaw, that's a treasure trove. But it has that groove. And this was actually the very first venom groove that was found. And the late, just passed away a couple weeks ago, Hans-Dieter Seuss described this out of the Smithsonian. So I made it look like a Gila monster, but active. Could have been passive. But we have a cool single tooth, but that tooth was a venom groove. So Arizona has 2/3 of all venomous reptiles back in 235 million years ago, right in our backyard, and we have 1 of 2 venomous lizards today. So for whatever reason, our state really loves them some venom. Now we have an animal called Van Clevia, which was named after someone whose last name was Van Cleve. Usually big donors or people that are very important, you'll name something after them. Usually a species, which is Campi, and in this case, Camp was a paleontologist that was finding lots of cool things. Now, what you have here is this was all they found of it originally. So if you go back, this was 1995, all they had was some bones, some vertebrae, part of a jaw. They knew it was new, but this was all they had of it. Well, you keep looking and you find skeletons. And so happily, they found this skull with these osteoderms, and then they found this with actual osteoderms in place, so like a croc-like skin. This is in New Mexico at Ghost Ranch. So when they found this, it turned over what we thought. We went from we've never seen vertebrae like this, we call it Van Clevia. But it had the same bones that had been described, so we knew we had Van Clevia. But now we know that this thing had a really amazing skull. I mean, look at these teeth. That's just so cool to me. I'm like, oh my gosh. Now, that's a centimeter scale, so we're not talking about, it's an animal 7, 8 feet long. But it's an aquatic, so it's kind of like a crocodile of sorts in the sense that it's got osteoderms, but it's got them all over the body. We did not expect this thing to be aquatic, but when you look at the features that are on its limb bones that were present, it was clearly swimming, or at least semi-aquatic. So that was a shock because you don't normally expect to see heavily armored animals, minus turtles, swimming around. Just shows the diversity of life that was present in Arizona, and the reptiles were going crazy 235 million years ago. Now there's lots of species of Trilophosaurus. We've got a couple of them named from Arizona. So Trilophosaurus means three loaf, 3 keels. And it's a feature on this tooth. It's got these 3 little bumps here. And that's kind of cool, and that's all we had of it for a long time. You're like, well, that's a yawner. But again, we had never found a tooth like that. So we find a bit of bone, and you look at your hand lens, and you don't recognize it. Well, you get to name it. That's cool. And there's some more teeth. And then we find more recently, jaws. We started finding jaws with these teeth in them. We're like, all right, now we're getting somewhere. That's why it's called research. It means search again. Literally, I retie my shoes daily. I research as well. And then there's more teeth that are found. You can see the 3 loaves. So we know it's the same animal. And more jaws come up, more teeth. And then we find skulls. So people are still looking. I mean, every single year, people are out looking for fossils. And this is a success story, because then we hit pay dirt and we get a lot of the skeleton with these gorgeous hands. And now we can start figuring out what we actually have. So at the American Museum of Natural History, you'll go see this specimen on display. It's a cast. And here's a reconstruction of it. But there's been debate. With those beautiful hands, some people have argued it climbs trees. So paleontology is a speculative science that we try to tie the ability to test our speculations with. So with those hands, we can start making predictions. So some people argued that those big, long, sprawling hands and the way it's built would have been arboreal of some sort. So there was a raging debate in the 80s and 90s over this. I think it's quelled down now because Trilophosaurus isn't all that popular outside of the obscure science circles. But it gets even better because you have Ankistrodonychus. So you're like, all right, Deinonychus, it's got to be something cool. There's a kind of reptile that makes no sense. It's called a Drepanosaur. Think of a chameleon, but the tip of the tail has a massive, massive claw on the tip of the tail about the size of your thumb. Why do you put a massive claw on the tip of the tail? No one knows. There are lots of hypotheses. So what did we do? We found a claw. A single claw, and that's what they found. And they knew that this claw made no sense. It was unlike any claw that had ever been seen, but was similar to Drepanosaur. So they named it that unpronounceable name. And then they tried to argue, well, maybe it's arboreal. So they're doing all of the science of here's what birds and ground-dwelling birds, perching birds, climbing birds. They take all of these claw angles. They make all these comparisons. So we really do try really hard when we make statements to do whatever we can to prove, or at least to a justifiable hypothesis of what we're up to. So here's a picture of it. What's off screen is this giant claw. So many people think they're arboreal, using these huge claws to scale trees. However, Skybelonyx, the dung claw, which I'm sure they had a lot of fun coming up. What do we want to call this thing? Again, this was in 2020. This is all they found, a single claw. You're like, why would you name it? Well, because of some of these structures, we know it belongs to a Drepanosaur, but it doesn't look like any other Drepanosaur ever found. This claw is as long as its radius. So imagine if you had your second finger, had a claw on it that was this long. It reminds me of that guy in the Guinness Book of World Records with those long claws that creeped me out as a kid. It's gross. But that's what it had. So they're trying to say, well, maybe this thing is arboreal because look at all these claws and it plots over in here. So it must have dug in the ground. So I drew it both ways. Maybe it climbed trees. Maybe it used these to burrow. So the paleontologists in the Drepanosphere space or Drepanosaur space are very active. And there is if you get on a Discord, it's in the name. Don't go on Discord. It's terrible. But these folks battle, heated rivals over, they climb, they dig. None of you had heard of Drepanosaur before you walked in. You would be surprised at the 18 people that are vociferously drawn battle lines like the Civil War, and they just throw artillery at one another. It's terrible. So I drew him in a cute little burrow because, I like burrows. Puercosuchus, something we can say. Well, this is our good friend Sterling Nesbitt's in the middle. This is out at Petrified Forest, and they found this. They found a jaw, an upper jaw, the premax, so right up in front of the snout and the area behind it. And then they found the lower jaw, and they had all these great teeth. And so they have a lot of the skull, and they were able to take those skull bones and look at all the other skulls that had ever been found and realize this was something new. So it looked something like this, but all they have is the skull. So what happens? Where's the postcrania? We have no idea what the body, anything past this area is wild speculation. Now I say that, but that's not altogether true. Because we know it's related to other animals and we can look at what their bodies look like. So we make an assumption that if I find teeth that look similar to a dog, but they're kind of different, the body's probably going to look similar to a dog. And that's comparative anatomy. Now, Echidostrophius. I love Tanystrophiids, an animal you may not have heard of. I went to Switzerland recently to look at them. They are extremely long-necked animals that have bodies that are just kind of dumping around and tinyish tails. They swim on the water. No one knows what they're doing. And I'll show you a picture of one here in a moment. So when I just learned that we had one of these in Arizona, and I didn't learn this until a week ago, I was very sad, because if I had known this, I could have went and had a lot more excuse to open up the Tanystropheus cases. Instead of looking through the glass, I could have the glass down and justified looking at them and touching them. Bucket list. So I got to go back. This is a long neck bone. So that's a centimeter. It's 2.5 centimeters long, which is really long for this kind of animal's neck. And what was wild about this was they found these spikes on top of the bones in the neck and the front of the back. It's never been seen before. So when you see this, you're like, oh, that's a Tanystropheid. I know what that is. Cool. You see this, you're like, what? So they CT scanned it because they thought maybe it was an error, like a taphonomic misprint or something. But no, it's legit. So it's got spikes that run down. Why would you have spikes? Well, it kind of made sense to me once I saw it, because we saw in Switzerland a bunch of these Tanystrophiids, and their necks are bitten in two. Animals, these mean-looking big crocodile-like critters, are biting the necks of these when they're swimming. So it's very tough if you have a neck that's really long, longer than your body, and you're out, you can't see them coming. And why would you have a long neck with a head on it? Because if you're going into a school of fish, they just see the head. They don't know what's behind it. So they're not really worried about something about their side. So you open their mouth and it's full of sharp teeth, and now they've been eaten. But there's always something bigger, was biting them. And they keep biting them right in here. They have 3 of them on display in Zurich. So now I need to go back and tell them, hey, have you heard of this one? We have spikes in Arizona. We evolved. We're smarter than yours. We do talk, we'll leave it. There's lots of banter amongst paleo folks. So now you have Centome prosopis. That was one I had to practice on there. That was tough. And our good friend Sterling was involved. That's what we found. A stubby, snub-nosed jaw. They found 4 total jaws. Only the jaws, all in the same spot, all short, squat jaws, and they have this weird bone texture on them. And bone texture exists in amphibians on the back of their skulls quite often. So this was cool to see. But that's it. So how do you illustrate it? If you're an artist and you only have so much time in a day, would you choose to draw the Centome prosopis? No, but it had a short bulldog jaw. So next time you all are out hanging out in the petrified forest area or working with the crews, go find more of this, because that weird jaw is going to probably have a cool body that's way better than this. Now, one of my favorites, Smilosukis. You've heard of Smilodon, scalpel tooth. Well, this is scalpel crocodile. And you're wondering, wow, that's a pretty bold name. Why did they name this? And that's because they found this. This is the longest and largest of the phytosaurs. Phytosaur means plant lizard, because when it was found, the lower jaw had all of these pegs that they assumed were flat. Well, what it really was is all the teeth had fallen out, and they were mud plugs. So they got it wrong, the German scientists. I love when the Germans get it wrong, because they're so precise. And they misnamed what turned out to be one of the most important and colorful groups of reptiles that ever lived. I'll point out that this snout here is bent and curved because that's how they found it, but they weren't sure how much deformation is. And that's a problem. If you have a long snout and you die in 235 million years, you're in the ground and the earth moves and you've got plate tectonics and things are walking around, you get what's called plastic deformation. So you always got to be careful when you're looking at bones to make sure that that's the real morphology. So they gave really nice illustrations, these beautiful drawings. They had a couple teeth in the jaw. You can see these long wishbone-shaped jaws. This thing's 30 feet long, 25, 30 feet. So we commissioned an artist to draw a skull because I thought they were so cool. I wanted to see one and label the bones because we find complete skulls of these. There's dozens of phytosaurs. If you go to New Mexico, if you visit northern Arizona, you visit Utah, they're going to have beautiful, real, complete phytosaur skulls. We have one on display here. In the museum is Leptosuchus. So you can go see a much smaller version of this animal right down in the museum afterwards. Now they have these narrow top to bottom skulls, very cool. A feature I want to point out, because I study vertebrae, so I was really kind of frustrated because all I wanted to see was verts. How many have we seen so far? 3. So now we've got a bunch. Notice this little handle on top. Like, why in the world does it have a handle? What the heck? Well, that's because they found these scutes, kind of like an alligator. So these handles have the osteoderms right down the center of the body, and they're supported by the vertebrae. I thought that was a pretty cool solution. So here's a drawing of it in life, almost as long as a big yellow school bus. I would definitely have been terrified. I've been near saltwater crocs, which are terrifying, especially when, well, that's a story for another day. Before one relieves oneself, one should read the sign, because as I was standing there relieving myself, the sign said saltwater croc area, extremely dangerous. And yeah, that was very quick and terrible. So this is a Cainosuchus. I want to lament about this one because it frustrates me. That's all we have of it. One scute, one piece of body armor, if you will. What's the point? But it looks different. These patterns actually become extraordinarily important to paleontologists that study these animals. So this is what it might have looked like. That's Andrea Tukin's work. No idea. Your guess is as good as his. I don't know what to tell you, except that scute had patterns never seen before. Now, AZMNH, similar. Now we're going to a world called aedosaurs. Think of pangolin, aardvark, armadillo, heavily armored turtles that had really cute snouts. But unfortunately, all we found was this and a leg bone. Yay, we found something other than a scute. But this pattern is unique. And so because this pattern told the paleontologists, hey, we have a different kind of animal here. How exciting. So they named it. So you're going to find I took the easy way out. I just made different armor patterns because no one knows what these look like for sure. All right, let's all say it with me together. Cryphioparma, yeah. Sounds like a cheese or some kind of something you'd find somewhere in a drugstore. But the hidden shield is named because that's all we found of it. There you go. You got 3 bones, but notice the pattern is very different. Paleontologists, don't play Where's Waldo with us because we'll win. We're good at finding patterns, recognizing pattern, and finding that missing element. So this paper is showing how this bone is different than all these other ones because all of these are individual kinds of these aedosaurs. They take their armor seriously, those folks up in the petrified forest. So I made that one. Its guess is as good as mine. But it shows you the diversity. 10 million years sooner, and we're not talking about amphibians. All we're talking about is armored reptiles. I mean, the Tanystrophe had spikes on its back. So it's a tough time to live, and the reason, in large part, is because of phytosaurs. They will eat you, so you need to be able to survive those massive killer croc-like critters. Here is Scutarchs, the shield fortress. Yay. Another armor. I shouldn't say that. I really like it. They're really cute to see. But they found a skull. And they were super excited because when you find a skull, that's cause for joy because that's grant money coming in. And there you go. Might have looked something like that. We are now done with the aedosaurs. We're still in the reptiles. I'm going to show you one of my favorite combinations. Shuvasaurid, poposauroid, pseudosaucian. Yeah, you got all of this means very specific things to the folks that study Shuvasaur, poposaurs, and pseudosaucians. Sterling's wife named this in 2012, Michelle Stocker, brilliant paleobotanist, absolutely wonderful human, and she found a skull. So imagine that. You study plants. All you want to do is find plants, and you find a skull. You got to publish on it because it's new. It's exciting. And just like our broken skull from before, it's missing a chunk in the center. But protome, or protome, is pretty cool. They found part of the skull as well, the back of the brain case, and it's a reptile that converged upon, if you go back to the beginning, our amphibian with the long snout. Long snouts appear again and again and again. Ichthyosaur, Spinosaurus, dozens of long-snouted reptiles exist. Choristodores, Champsosaurs. Now, Soncellosuchus is named after the formation, the member of the Soncella in the Chinle Formation. And you're wondering, what's this? Well, this is another Shuvasauroid, poposaurid, pseudosaucian. And we found the front of the snout. So they found a beak, and that's kind of cool. And then they found a little bit of the back of the skull and a part of the lower jaw, and they got to name it. But they found a vertebrate, and I was so happy. But I don't study these, so it was just cool to see. Finally, something other than armor. This is how their artist that they hired, Gabriel Ubgeto, who's amazing. That's how he chose to draw it. Good luck. All you got's a skull. Now, Acalosuchus is called ugly crocodile. I nominate this for the most ridiculous initial discovery drawing in the history of paleontology. Yes. Thank you, Camp. We named things after you, and you gave us this. So Camp found a skull, and that's all he gave us, and he gave us some notes of where he found it. So bless Long and Murray, because they wouldn't found it. Now I see why he drew it, because look at this. This is utterly just distorted and messed up. So I like that actually better after I saw the original. So I looked at a more modern paper. They tried their best to make it look good. What you're looking at is a part of the skull. But this is a part of the skull that matched no other animal skull part, so they named it Ugly Crocodile based on what they found. So it'd be really nice to find some more, because I'm sure it's beautiful if we could find the whole skull. So I drew it like this because some people have posited somehow based on the skull that it was walking around on its hind legs, whereas others argue it's on its forelegs. Paleontologists will fight over a scrap of bone, and there's an example of it. It's always cool. Now, one of my favorites, Hesperosaucus. Colbert, Ned Colbert, who was one of the great paleontologists. He actually retired. Museum of Northern Arizona has an endowed chair for Ned Colbert. I met him in his retired times. Absolutely gracious human being. He found this block of bone, and he was able to pull some skull bits out, and this is his paper. And here's pictures, and this is in the 40s, of him working on the side of the cliff in Cameroon. So if you're driving northern Arizona, you've driven by these on the right side of the road in 40-something, you would have seen him out there digging. And they set up a little site, pulled out a bunch of skull fragments, a bunch of vertebrae, scutes that were articulated. They found 8 of them. That's super exciting. More vertebrae. And he never published this. Colbert was at the American Museum of Natural History. He laid the skeleton out, had this great photo taken of it, and then didn't do anything with it. So it's an unpublished negative. So historians can make amazing discoveries in paleontology by just looking through the archives and notes from the old timers. Now I got a vent, and maybe it's not their fault. They assumed you were looking at the actual manuscript in physical form. So no scale bar anywhere. This is 1/4 natural size. I have no idea what to do with that. 1/4 of that? I don't know. So it's quite maddening in today's digital world to get a PDF, and I don't know what the original size was. So I have no way to know. And if they don't give me any measurements in the paper, I'm utterly lost. He drew, which was rare for the time, he drew a restoration. I love the look he's giving. Art, that's talented to give you that cute side. It's almost like he's winking. It's like, hey, how you? I'm doing cool. So I love Hesperosaucus. He's so delightful. So I drew him like this because I can't see him walking around like that, but I really should someday. Now, I'm going to shift gears literally to Eotepharodactylus. Dactylus, that's a word you're all hearing. And this is a lower jaw of a pterosaur, a flying reptile. And they found the arm bone. They found one of the bones in the arm, I should say, and the shoulder. And pterosaur shoulders are unique. They all look like this, and then they have subtle differences. So Arizona had an animal flying in the skies 235 million years ago. Absolutely delightful. Because of its teeth, it's likely a rhamphorhynchoid, which means it would have had a really long tail, and it would have ended in a vein, in a spade-shaped vein that was likely aerodynamic. Super neat to know that pterosaurs flew around. I did not know that, so now I know. Camposaurus, hooray, we're finally to dinosaurs. And we named it after Camp, the guy who gave us that great illustration. And this is what we have of it. Yeah, I've got the bottom side of 2 vertebrae and the bottom end of a tibia. Someone went back and gave us a new picture, because this was named in 1998. We had color then, guys. We could have splurged, but we didn't. So in 2016, these kind folks, Sterling Nesbitt being one of them, said, we need a better photo. But that's it. We have that bone and the other vertebrae, and yet somehow, thanks, and actually because of comparative anatomy, it's very similar to Coelophysis, that meat-eating dinosaur from Ghost Ranch that everyone loves. What does this mean? Dinosaurs are now coming on the scene, but they're tiny. There's no scale bar in any of my pictures, and for that I should put me as silhouette next time. But this is like a giant turkey. So it's a very small dinosaur. This was not a threat to most of the animals we've talked about right now. Dinosaurs, you would have never, if you had to bet money 235 million years ago, who was going to rule the next 100 and some million years, you would have not put your money on them. I would have went all in on Phytosaurs, personally. I'd say take it, mortgage the house. I would have been badly wrong. Another dinosaur is called Chindosaurus, named the ghost lizard. And this is the cool thing. They drew a skeleton, and you're thinking, all right. Well, notice it's a holotype, but they found more of it. So they combined two different skeletons. And I'm just going to flip through all these vertebrae. We have a lot. This is the most we've seen of an animal thus far on our talks. Amazing amount of material. Absolutely incredible. It looks something like that. Another one of these small meat-eating dinosaurs, another turkey, big turkey-sized animal. Mammals finally show up in Arizona. Now, they may have been here before, but we didn't find them. And today, mammals are quite diverse, but these are all kinds of small mammals, predators. And I show you small things, but the first thing I'm going to show you is also the oldest animal named from Arizona Paleo. In 1904, a gentleman named Lucas named Placerius hesternus, which is this broad body. This is the only bone he found, at least initially, this big humerus, and of yesterday. So he knew it was old, and it was a mammal, and it was exciting. Someone took a modern picture of it and shows that what's great about pictures over time is you can see what's broken. And in this case, there's no breakage. Quite often, I'll find a picture from 100 years ago and I'll see that parts are missing. I'm like, what happened? It got moved around, damaged during transport, etc. What's great about this is a Placerius. Later on, fast forward almost 100 years, they find this skull. So Spencer Lucas from New Mexico found this chunk of bone, which, believe it or not, is a skull. I just thought it was scrap. I would have moved on. But then some folks that work on these out of South Africa said, no, you got it wrong, Spencer. And I always like when Spencer's wrong. And we had to move it to the other direction. And there's its eye, and we're having a good time. But it looked like this. They lived in herds. There's something called the Placerius quarry. Where that bone came from turned out to be the largest concentration of these animals ever found. And there's hundreds or thousands of bones from this place. Absolutely amazing. And in the process of excavating these bones, what I didn't point out was a lot of the animals, the tiny ones that have been found, were found at this locality. Taking out all these big bones, you get it in the lab, and then you're carefully preparing away, and you find all these small teeth. It's pretty cool. All right, help me out on this one. Cataegidododon? I'll go with it. I have no idea. I apologize. But this is another mammal, and that's what we found of it. This tiny jaw chunk. But the tooth let us know that this is a mammal, and mammals are super popular. So they did it the scanning electron microscope treatment. When you only have one bone with a tooth in it, you will do anything to make your paper longer and try to get more money out of it. But this is my favorite picture. I love the scale chasing a dragonfly. Who knows if that's what it looks like? We got a chunk of jaw the size of my thumbnail, smaller even. But I just love the picture, so I had to show that one off. And now, Craterochirodon, bowl-handed tooth. Now this was named in 2005. There was actually two teeth. The aforementioned Ned Colbert had one in his lab. He borrowed it. It's lost. So we have one tooth that's at the petrified forest. Ned died. They went through everything. They could not find it. What's wild is all we can tell you about this, and is it Bill Parker, great paleontologist at Petrified Forest? You've got the tooth jaw, and you've got a tooth in it. This tooth is like no tooth we've ever seen. So much so that all they're willing to say is, it's a mammal. We have no idea what kind of mammal it is. It is an utter mystery. And we have been working over 100 years in this part of the park, and that's the only one tooth we found two teeth, and one's gone. So someday, someone somewhere is going to find it because it's so distinct and unique, and it'll be really exciting. Now we're going to move forward. We're going to jump 40 million years because we don't have any rocks with fossils in them. We're now in the Jurassic, and it's wet with big monsoons. Hey, it sounds very similar. And it looks kind of like this. There's not a lot that's been found there, but it's all again in the northeastern Arizona. If you like fossils, that's where you go. Amphibians. We have the world's oldest frog. Yeah, this vomity looking splotch of gray and other gray is actually, when you get into it, a frog. It's a jumping frog. So it was really cool that Arizona has the oldest Sicilian amphibian and the oldest frog amphibian. And then, speaking of Sicilian, the former oldest Sicilian, Eosicilian, the Dawn Sicilian, has a skull. Yep, that's a skull. These are tiny animals. They don't blow up well. And to put this is 1993. Jenkins and Walsh pulled out all the stops, ran it through the highest tech scanners at the time, and that's what we got. You'd think someone would go run it through something more modern today. But that's what we have. These are stereo pairs. Before this thing called Polycam, and you could spin things around, you put the slightly offset photos and then blur your eyes, and it jumps out in 3D. You know, people are clever. You work with what you got. But this is what they think it looks like. Beautiful skull, very unique teeth. It's a caecilian, very cool. Arizona is legendary for caecilians. And this is a nice drawing of what it may have looked like. That's it. Our amphibians are done. We're moving into the reptiles again. Kayenta I thought of you, Bob. The Kayenta turtle. And there it is. There's the drawing that came out of it. That was when it was published in '87. What I bring your attention to is this is the skull, and you're looking at the roof of the mouth. It's loaded with with teeth. A turtle with teeth on the roof of its mouth. So that's something that's kind of different and unique. And there's pictures of the skull from the top, and that might have been what it looked like, but Bob will probably tell me tomorrow when we're at the bar that that's the completely wrong turtle, and I respect that because I'll get it right. Navajo sphenodon. You may have heard me talking about my bucket list sphenodontian, the tuataran. Well, we found this. I did not, but that is a skull and a complete body. Thankfully, with today's modern CT scans, we were able to go through and identify all of the bones, including all the skull bones. This is an amazing specimen. And they took all kinds of effort to show off. They didn't find just one. They found multiples. They found juveniles. They found late juveniles. And they found adults. So you can see something called ontogeny. I didn't know this specimen existed. Now I want to go touch it because this is cool. And it looks something like that. Sphenodons have been around since the beginning of our talk, and they're still alive today, hanging out down in the Oceania. Almost done. Calsoyasuchus, my friend Ron Tykowski named this, and he found this skull. And it looks kind of like a phytosaur if you're thinking back, but it's not a phytosaur. It's a bit different of an animal, crocodile of some sort, crocodiliform form of crocodile. And we have nice pictures because now we're in modern times. Long snout. So now we've got a crocodile with a really long snout. They're getting in on the action. Eoneumatasuchus, we've got another one of these crocodilomorphs. The skull's important because it has pneumatic characters, and it's so important that people went back and have done all kinds of brain studies on this as well to try to figure out what's going on with this animal. We have all the cranial nerves for you anatomy folks out there, so that was kind of helpful. Lots of illustrations, and that's what it might have looked like. Kayentasuchus, another one of these critters. That's the drawing. You like it when you get CT scans versus if I'm trying to see that I find this animal. It is frustrating. That's why paleontologists travel so much, because we need to go touch the bones. Now we had this whole group of running crocodiles that had gracile limbs and ran around. Protosuchus is another brilliant one. This is the initial block that was found. Check that out. In fact, when I do this talk again, I'm just going to do the highlights, but I'm a completist, sorry. Look at that, the skull, the legs, you got the whole thing, amazing. And then they went and prepped the other side. We would not do this today. We would use a CT scanner. They risked it. They said, we'll just flip it over and prep at the other end. I can imagine how thin this thing must look. It's got to be terrifying to hold. Looks something like that, and we can be pretty confident because we've got the whole skeleton, which is cool. I didn't know that existed. And another pterosaur shows up. Ramphinion was named in 1984 off this, which is a chunk of jaw with the occipital condyle, the back of the brain case. But we know it's a pterosaur because we found some teeth and limbs. So we have pterosaurs flying around the Jurassic of Arizona, and we're finally to Dilophosaurus, the animal that everyone loves because Jurassic Park got it so wrong. This is the first published image of it, which I thought was kind of interesting because I had to dig deep to find this. And this was the first illustration of it. You see here, this is a baby Dilophosaurus. Is he advocating cannibalism, like child abuse? Or is he chasing an errant child? We have no idea what's meant. I don't know. I'm trying to get the theme. But it was a beautiful painting in black and white, and I was so glad to see it. This is the skeleton. When he published it originally, no crest. He did not know that it had a crest on its skull for 20 years. And then they got around to prepping the skull and said, whoa, wait a second. What is this? That's not one crest, it's two. So Adam Marsh did his dissertation on it and gave us all kinds of great photos, commissioned some artwork to have the two crests. We have Dilophosaurus on display in the museum and outside. Megapnosaurus. This is the malevolency of academics. This used to be called Centarsus, but Centarsus actually was used for a beetle. So the beetle people that figured out that the name was occupied, you can't use the same name for two organisms. When you find the mistake, you get to rename it. They named it Big Dead Lizard. So they had a sense of humor. I mean, I'll give them credit, but these folks they cannot go to a dinosaur conference or they will be removed. They're on the wall as like, do not enter, do not allow to be in. They have the whole skull. I mean, this specimen's gorgeous and beautiful. And to have Big Dead Lizard as a name, that's rough. I mean, that's just a tough break. There he is, though, hanging out, meat-eating dinosaur. Supersaurus. I didn't know about this animal until a few years ago, and that's embarrassing. This is a really nice, look at these hands. I mean, this is a sauropodomorph. We just looked at some in Switzerland, and it looks just like this. It was really cool. We've got skull material of it. How do we, none of us, this should be, every child should know about Supersaurus. I think it's because it's the name. I mean, Sarah smiles, maybe Hall & Oates should get in on it. Scutellosaurus is yet another one. This is a dinosaur that's from Arizona, and it's armored. We found, this is great. This is what you see. This is what they actually drew. You've got skull elements. You've got all of these osteoderms, these armor on a dinosaur that's walking around on 2, maybe 4 legs, who knows. They have a tail. I study tails, so I spent a lot of time staring at this going, wow, this is beautiful. And these are the bits of bone, osteoderms on it. This is a fantastic specimen. The illustrations are amazing. I mean, look what they did. They were so kind. And now someone's gone back and taken pictures of the skull. This is what it looks like. How do we not teach our school kids about Scutellosaurus and Supersaurus? There ought to be a law that makes that happen. And we have mammals in the Jurassic. We have some of the best mammals around. The Dinabitodon, which is this critter here. Doesn't look like much because it isn't. It's a couple of teeth. And we'll move on. But if you're a mammal person, you would slap me right now because it's very important to mammals, but not to us. Dinatherium. Because once you're on the reservation lands where these are being collected, they began using more appropriate, respecting the folks whose land it is. Now, this specimen was amazing. In 1983, they found a jaw with teeth. This was nature. This was the top of the pinnacle, best of the best. They went and took high-end technology in '83 on it. They even did scanning electron microscopy, which was very, very expensive back then, but they were at Harvard. They have a big endowment. It was okay. And it looks something like that, a little tiny mammal. I mean, this is a mammal eating a cockroach-like size animal. These are small, small animals. And Kayentatherium. Yep, that's kind of cool, I guess, if you like mammals. A lot of teeth. But what they ended up finding, though, was a nest, and you got the whole body. And they lived in family groups like mammals today. A burrow was caved in, some cool stuff. So we just got to keep looking. And now we're at the last 2. We're moving into the Jurassic. If you have the largest sand dune in the world that's ever been on our planet, think dune. That's this, Segisaurus. Found some bones, found some more bones, found some more bones, a lot of bones, and that's what it looks like. And we're at the last one. I saved the best for last because I study sauropods, and you already know where we're going here. Now we're down in southeastern Arizona, Sonorosaurus. These are the bones that were published in the original paper, but that's what it looks like. It's a brachiosaur. It's medium-sized. It's about the size. It's smaller than our Camarasaurus out there. Fantastic. We finally got a sauropod in Arizona. I only had to go through 58 taxa. If I had just started at the most recent time, I would have been done immediately. So I put 2 images plus of me for scale. Never crossed the radius and ulna. They clearly thought it was a mammalian. That would break the arm immediately. It's really sad. I giggle. And this is the block of the rest of it was found in, right here. And that's it. That was a speed bag of Arizona dinosaurs. You've now heard them all.